Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Modulation can be classified in various types. The choice of the modulation for the given system depends on the technical goals such as maximizing data rates, improving noise resistance, and practical constraints, for example, cost, available bandwidth, power resources. Each modulation scheme makes trade offs in complexities, bandwidth, power, and noise immunity, allowing engineer to tailor communication system for specific use cases and performance requirement. These trade-offs are what enable the wide variety of communication technology we use today, from basic amplitude modulation radios to the advanced 5G and 6G networks. In the previous unit 9, we explored and discussed the concept of modulation. Now we are going to discuss the different types of modulation, both analog and digital, and then analog modulation is further classified and digital modulation is further classified. They are the used in transmitter and receiver as a building block, and still it is a part of chapter 3. Modulation play a critical role in enabling the transmission of information over various medium and distances, whether it is through radio waves, fiber optics, or even satellite links. Without modulation, many of the communication technologies we rely on, like mobile phone, television, and the internet, would not be possible. So, what is the modulation? As it is the core, it is the process of modifying a carrier signal to encode information. This allows the signal to be transmitted efficiently across long distances and through diverse environments. The choice of modulation technique, however, is not arbitrary. It depends on several factors that influence how communication systems are designed. First, the nature of the its signal itself. Is it analog like voice or music, or digital like binary data we use for the text and video? Analog modulation methods like amplitude modulation, frequency modulation, and suitable for the continuous signal, while digital modulation is scheme like phase shifting, PSK, and quadrature amplitude modulation handle high speed data transmission. Next is the data rate. How fast the information needs to be sent. For applications like video streaming or high speed internet, advanced digital modulation techniques maximize the data throughput. These methods allow us to transmit more information in less amount of time, make them highly essential for modern networks like 4G and 5G. Then there is a bandwidth, a limited and precious resource in communication system. Efficient modulation techniques such as OFDM are designed to make the most of available spectrum, allowing multiple users to share the same frequency bandwidth without interferences. Similarly, noise resistance is another key factor. Signals often encounter noise and distortion as they travel, especially over long distance. Techniques like FM, frequency modulation, or phase modulation excel in noisy environment because they encode information in way such that they are less susceptible to the interferences. Finally, we must consider hardware complexity. Simple methods like AM are cost effective and easy to implement, making them suitable for basic application. However, more sophisticated techniques like quadrature amplitude modulation or orthogonal frequency division multiplexing, while demanding in terms of processing power, are crucial for high performance systems like fiber optic communication and wireless bands. So finally, we can say that modulation is not just a technical concept. It is the backbone of modern communication system, striking a balance between performance, efficiency, and practicality. It enables us to connect, share, and innovate in ways that have transformed our world. Whether it is transforming a radio broadcast or streaming a live video across continents, modulation is silent hero behind it all. As discussed above, modulation is a process of encoding information onto a carrier signal, can be broadly categorized into analog modulation and digital modulation, depending on the type of information being transmitted. Analog modulation play a vital role in communication by transmitting continuous signal like voice or music. There are three main types of analog modulation, such as amplitude modulation, frequency modulation, and phase modulation. Firstly, we discuss about amplitude modulation in little detail. Amplitude modulation, one of the earliest and simplest form of modulation. In amplitude modulation, the amplitude of the carrier wave is varied in accordance to the message signal itself, while the frequency and phase remain constant. This process allows information like voice or music to be transmitted over long distance. Amplitude modulation has been the cornerstone of communication, especially in radio broadcasting, where it delivered talks, show, news, and entertainment. Beyond broadcasting, amplitude modulation is widely used in aviation communication, especially in the VHF AM band, ensuring reliable communication between pilots and air traffic control. Additionally, it is employed in two-way communication, making it valuable for emergency and military communication. Although amplitude modulation is simple and cost-effective, it's more susceptible to noise and less bandwidth efficient compared to the modulation technique. Nonetheless, it remains a key player in many critical communication systems. Let's take a quick look at the pros and cons of amplitude modulation. A fundamental techniques in communication, starting with the pros, AM is remarkably simple to implement, requiring basic hardware for both transmission and reception. This simplicity make it cost effective and widely accessible. Additionally, AM is highly compatible with older receiver while ensure its usability in legacy system like traditional radios. However, amplitude modulation also has its cons. It is prone to noise and interference. As external factors like weather and electrical noise can easily distort the amplitude of the signal. This results in lower sound quality, especially over long distance communication. Furthermore, amplitude modulation has low spectral efficiency, meaning it uses more bandwidth than necessary for the amount of information transmitted, making it less suitable for modern bandwidth limited systems. Now we define spectral efficiency is the critical measure of how effectively a communication system utilizes the available bandwidth to transmit data. It is typically expressed in bits per second per hertz, indicating how many bits can be transmitted per unit of bandwidth. Higher spectral efficiency means more data can be transmitted within a given bandwidth, which is crucial for optimizing channel usage, especially in systems with limited spectrum. In amplitude modulation, the spectral efficiency is relatively low. Amplitude modulation typically require a bandwidth that is at least twice the frequency of message signal as discussed above, making it inefficient in terms of bandwidth utilization. For instance, if the message signal has a bandwidth of FM hertz, the total bandwidth required for AM is twice of the FM. And this results in spectral efficiency of around 1 bits per second per hertz or less, which is much lower compared to the modern digital scheme like quadrature amplitude modulation or orthogonal frequency division multiplexing, which can achieve higher efficiency by transmitting multiple bits per symbol. Frequency modulation is a widely used technique in modern communication systems that offers several advantages over other modulation tech methods like amplitude modulation. In FM or frequency modulation, the frequency of the carrier wave is varied in proportion to the instantaneous amplitude of the message signal, while the amplitude remains constant. This means that the information is encoded in frequency changes rather than amplitude, which provides significant benefits over amplitude modulation, especially in terms of sound of quality and noise resistance. FM is particularly popular in FM radio broadcasting, where it offers superior sound quality, making it ideal for music and high fidelity broadcast. It's also used in television audio to transmit high frequency sound alongside the video signal. Additionally, FM play a key role in high fidelity wireless communication system like walkie-talkies and two-way radios communication, where clear voice transmission is critically special and especially in noisy environment. Now let's explore the pros and cons of FM. One of the main advantage of frequency modulation is its better noise immunity compared to the amplitude modulation. Since the information is encoded in frequency rather than amplitude, FM is less affected by common interferences like static or electrical noise, leading to clear communication. Furthermore, frequency modulation provides high sound quality, which is why it's preferred for music and high definition audio transmission. However, frequency modulation does have its drawback. One of its primary cons is that frequency modulation required a larger bandwidth than amplitude modulation. While AM uses a narrow bandwidth, FM's broader bandwidth requirement can make it less efficient in terms of spectral usage, especially in crowded frequency band. This is one reason why FM radio stations are spaced further apart compared to the amplitude modulation station. In phase modulation, the phase of carrier wave is varied in proportion to the instantaneous amplitude of the message signal, while the amplitude as well as frequency remain constant. This means that the message information is encoded in the phase shift of the carrier wave and making it a highly effective technique for many advanced and modern digital communication systems. Phase modulation has several important applications. It is used in digital transmission systems such as Wi-Fi, where it is a part of more complex scheme like quadrature amplitude modulation. We also called it QAM to transmit data efficiently. Additionally, phase modulation is the key component of the global positioning system. We call it GPS, where it helps to achieve accurate timing and positioning signals. Now let's look at the pros and cons of phase modulation. One of the main advantages is its high resistance to signal degradation. Since the information is encoded in phase, phase modulation is much more robust against noise and interferences compared to other modulation technique like amplitude modulation, maybe sometimes frequency modulation, especially over long distance. This makes phase modulation ideal for reliable communication systems. Its environment too prone to signal distortion where lot of impurities and noise are available, so phase modulation is superior with many other modulation techniques. Furthermore, phase modulation is efficient for analog as well as digital communication, allowing it to support high-speed data transmission with lower error rates, making it vital for technologies like Wi-Fi and GPS. However, there are some disadvantages of phase modulation. Some most important is that the demodulation process in phase modulation is more complex compared to simpler modulation method like amplitude modulation or frequency modulation. This complexity requires advanced signal processing techniques and more sophisticated hardware, which can increase the cost and power consumption of the system overall. Digital modulation is a technique used to transmit digital data, and specifically bits, over a long communication channel. Digital modulation is very vital for modern communication system such as mobile communication network, satellite communication network, and similarly internet data transmission, as it enables efficient and reliable transfer of information. One of the key type of digital modulation is amplitude shift keying, which is being discussed here. In ASK, the amplitude of the carrier signal is varied between two or more discrete labels, each representing binary data, just you know that zeros and one. This makes ASK is relatively very straightforward and efficient method for transmitting digital signal over a channel. ASK is commonly used in application like optical fiber communication, where light signals are modulated to carry data and simple RFID system. Where the presence of signal is encoded information, one of the main disadvantage of ASK is its simplicity, and it is advantage is its simplicity because it is easy to implement and making it a cost effective choice for basic communication system. However, the disadvantage of ASK is that it is susceptible to noise and interferences. Since information is carried by amplitude variation, any noise that affects the amplitude of the signal can also distort the data and reducing the reliability of the transmission. This makes amplitude shift keying less suitable for environment where high interference or high speed data communication take place. Another digital modulation technique which is commonly employed in many communication systems is frequency shift keying. The frequency of the carrier wave is altered between two or more than two discrete frequencies to represent binary data such as zeros and ones. The signal frequency changes based on the bit being transmitted, with different frequency corresponding to different binary values. It has many applications. One of the most practical application and commonly used in digital pager systems in where FSK is used in pager system to transmit very short message over a low frequency channel. Similarly, Bluetooth is also used FSK, and FSK is used in Bluetooth communication for short range as well as short data transfer, as it offers robust data transmission over a noisy environment. Short duration of the data transfer. And it has many advantages. More noise resistance than ASK. FSK is relatively less affected by the noise and interference as compared to the amplitude shift key, and making it more reliable, especially in environment where signals are degraded very quickly. Similarly, robust in low frequency shift keying performance is well in low frequency communication, providing clear data transmission over short to the medium distance. It has some drawbacks. Relatively required larger bandwidth than ASK. FSK required a wider bandwidth with ASK, as the system must accommodate multiple frequencies for binary data. This can reduce spectral efficiency, especially in bandwidth limited systems. Similarly, phase shift keying is a widely used digital modulation technique that play a key role in modern communication systems. In PSK, the phase of carrier signal is varied to represent binary data. The data is encoded by shifting the phase of the carrier, allowing the signal to carry more information in a given time. This phase modulation enables higher efficiency in transmitting data over various channels. There are several types of PSK, each offering different level of efficiency and data rates. The most important is binary PSK, which use two phases, 0 and 180 degree, to represent binary 0 and 1. Similarly, QPSK, quadrature PSK, expand on BPSK by using four phases, 0 degree, 90 degree, 180 degree, and 270 degree, allowing to represent 2 bits per symbol, increasing the ultimate data rate. Similarly, 8 PSK and 16 PSK use 8 or 16 phases respectively, enabling the transmission of more bits per symbol. Furthermore, it increases the data capacity of the system. PSK has found widespread uses in applications such as Wi-Fi, satellite communication, and digital television, where high data rates and reliability are essential. Now let's discuss the pros and cons of PSK. One of the major advantage is its high data rate and bandwidth efficiency. PSK allows more bits to be transmitted per symbol, maximizing the use of available bandwidth. Additionally, PSK offers better noise immunity than simpler modulation techniques, making it more reliable in noisy environment. However, PSK also comes with some challenges and may be considered as a disadvantages. It required more complex modulation and demodulation circuit compared to the simpler technique like amplitude shift keying or frequency shift keying. These more sophisticated systems demand higher processing power and can increase both cost and as well as power consumption.